In this lesson, we are going to continue to apply quadratic functions, this time to something called optimization problems. So optimization problems involves finding the maximum or minimum of some quantity. So for example, a business might be interested in minimizing costs or maximizing output. Right? A business wants to produce as much of a product as it can while getting its cost as low as it can. So we want to minimize the cost or maximize the quantity. Okay? So for a quadratic function, remember quadratics can be smiling like this or frowning like that. Okay? So when we have a smiling parabola, we have a minimum. When we have a frowning parabola, we have a maximum. And that optimal point, the point at which the minimum or maximum occurs, is the vertex. Okay? And a quick review of finding vertex, and this is for standard form. Okay? To find the x-coordinate of the vertex, you're going to use x equals negative b over 2a. To find the y-coordinate of the vertex, you're going to substitute x-coordinate, which you found over there, into the function. Okay? Let's take a look at a question. So number one, answer the following questions about the quadratic function. F of x equals 2x squared minus 16x plus 10. And of course, f of x, same thing as y equals. So, does the function have a minimum or maximum value? Well, this is essentially asking, does the graph smile or frown? The leading coefficient is positive, so it's going to look something like that. So, at its optimal point, we're at a minimum. So, it's got a minimum. What is the function's minimum or maximum value? So, it's essentially asking for the vertex. For the vertex, x equals negative b over 2a, which would be negative 16 over 2 times 2, which is 16 over 4, which is 4. Okay, and the y value of the vertex, we will substitute that 4 into the function, so it's 2 times 4 squared minus 16 times 4 plus 30. So we got 1632 minus 64 plus 30. So negative 32 plus 30, it's negative 2. Okay, so what is the function's minimum or maximum value? Well, the vertex is 4 comma negative 2. So the x-coordinate where the vertex occurs is 4, all right? And the actual minimum or maximum value of the functions, that's a y value. Okay, and it kind of gives away that this is an x value because the answer spot begins with x equals. This is an x value. Okay, so the y value for our vertex is negative 2, and again, that's a minimum. Okay, number 2 is a word problem. So we have this function c of x equals x squared minus 360x plus 37,657. And c is cost, and x is the number of planes made, number of engines made for the airplanes. Okay, so we want to know what is the minimum unit cost. So this function tells us the cost when we make x number of engines, all right? So this will be a smiling parabola, all right? The graph looks something like this. Notice I only included the first quadrant because negatives are meaningless here. You can't have negative engines. All right, so let's find that vertex. To get the x-coordinate of the vertex, x is negative b over 2a. So that'll be negative 360 over 2 times 1, which is 360 over 2, which is 180. Okay, so that means an x stands for is engines. So the number of engines produced in order to minimize cost is 180. So to get the y-coordinate, we'll substitute. It'll be 180 squared minus 360 times 180 plus 37,657. So that is, 1 second, I need to do this in my calculator. 180 squared minus 360 times 180 plus 37,657, which is 5,257. So it asks for the minimum unit cost, the minimum value, the production level, the number of engines where the minimum occurs is 180, but the cost of making that 180, those 180 engines, the unit cost is 5,257. That's what they're looking for. The answer says, what is the minimum unit cost? If the question asked, what is the level of production at which cost is minimized, then your answer would be 180. So you got to keep in mind, are they asking for cost or are they asking for engines? All right, number 3, a medical equipment industry manufactures x-ray machines. The unit cost, which is the cost in dollars to make each x-ray machine, depends on the number of machines made. So we've got C of x equals 1.1 x squared minus 638 x plus 106,380. So C is cost, x is number of machines. And we want to know what the minimum cost is. So that minimum occurs at the vertex, and this is a smiling parabola, again looking something like that. So we need to find that minimum, the vertex. So the x-coordinate, negative b over 2a, that'll be negative 638 over 2 times 1.1, so that's 638 over 2.2, which is 290. Okay, so that means we minimize unit cost when we produce 290 machines. To get the unit cost of producing 290 machines, we need the y-coordinate. So that'll be C equals 1.1 times 290 squared minus 638 times 290 plus 106, 380, which is 1.1 times 290 squared minus 638 times 290 plus 106, 380, 13,870. And that's dollars. All right, number 4 is a little different. A school wishes to form 3 sides of a rectangular playground using 320 meters of fencing. So we got 320 total meters to use. The playground borders the school building, so the 4th side does not need to be fencing. So this needs to be fenced. So does this. So does this. This does not need to be fenced because it's bordered It's right along the school. Okay, so when it needs to be fenced in, we need to add to our diagram. So in a rectangle, we know opposite sides are equal. So if this side is x, this side is also x. I don't know what this side is on the bottom, so I'm going to call it y. Well, between those three sides, we have 320 total meters to fence. So those three sides must add up to 320, or 2x plus y equals 320. Okay? And we know the area is length times width, or x times y. All right? But we want to have a function that involves only x, only in terms of x. So if we solve the first one for y, it'll be y equals 320 minus 2x, okay? And then instead of y, we substitute in here, so area is x times 320 minus 2x. Your area is 320x minus 2x squared. Okay, now if we think about what this function looks like, 320x minus 2x squared, it is a frowning parabola. Going to look something like that. It's going to have a maximum. All right, so let's get the vertex, the x-coordinate. It's helpful to rewrite this as negative. We write this in the proper form. So it'd be a of x equals negative 2x squared plus 320x. Okay, so the x-coordinate, x equals negative b over 2a. That'll be negative 320 over 2 times negative 2, which is 320 over 4, which is 80. Okay, and then, so the side length that gives the maximum area is 80 meters. And then what is the maximum area that the playground can have? We'll substitute that into the area formula. A equals negative 2 times 80 squared plus 320 times 80, which is negative 2 times 80 squared. Oops. Negative 2 times 80 squared plus 320 times 80, which is 12,800 square meters. So the maximum area is 12,800 square meters.